For those of you that aren't here right now, you should definitely watch the video. So I will definitely send an announcement as well, so everybody knows they should watch this first class video to get all the information. Let me minimize a couple things here. I don't need this up. Right on. Okay. So let us talk about the various things of the class. I'm gonna try and make it pretty easy to understand what's going on. For those of you that have taken the co-class with me before, things are pretty much the same as they were last quarter. Same sorts of assignments, same sorts of, really that's it kind of, right? Same grading scheme, nothing has really changed. But for those of you that haven't taken the co-class before or haven't taken one with me, let me go over the basics just so everyone understands what's happening. Most of it's spelled out on this home/syllabus page, right? So I'm sure you noticed if you click on the home or the syllabus page, it's the same thing. So here's all the info. If you've gotten here, you probably click this link. You can click this link for my office hours. I did not hold office hours today. Usually we don't hold office hours during the first week, but if you guys would like me to start having office hours this week, I definitely can. Maybe I'll post something in Canvas asking you guys if you want me to. So yeah, class meetings, office hours, Monday, Wednesday, Friday, 9 to 10, and right after class 2 to 3, and then Tuesday, Thursday, 11 to 12. I'll post this as well. Let me write myself a couple, keep saying things I'm going to post. Where did this pen come from? Yeah, I need to. Next week, I have to cancel a couple office hours because I am serving on a hiring committee. So I will definitely let you know when I won't be available. I think there's some on Monday and some on Wednesday that I won't be able to hold. But generally, these office hours, Monday, Wednesday, Friday, both 9 to 10 and 2 to 3, and then Tuesday, Thursday, 11 to 12. I will be available. You can just pop right in, ask questions about various things, homework, worksheets, other things, stuff we've done in co-class, whatever you want. Generally, I try not to help people specifically with their quiz or midterm problems. I don't think you guys have any midterms. I think you have like the 4 short tests, just like we did last quarter in Karan's class. So yeah, I'm not supposed to help with that stuff, but like other stuff, perfectly fine. In this class, I'm going to show you examples. You can definitely ask questions in class. Like if there's something like, hey, James, we'd really like to talk about this or have this very specific question I would like you to go over. Definitely happy to do so as long as it's pertinent. Let me do one thing. That's what I want. Sorry. Show me that. There we go. Trying to keep track of all the stuff here. And make sure the chat's up as well. You can definitely ask questions in the chat. I definitely saw lots of people writing things in the chat in Lewis's class today, which is great. I usually try to keep my eye on the chat. Sometimes I miss a thing. You're welcome to talk as well. I know not that, I mean, I don't love talking on someone else's Zoom teaching class, or really mine either. But if you can't get my attention via the chat, you're welcome to chat, to talk. You can also do the thing where you like raise your hand, which I never remember exactly where that is, and I can't see it right now because I've got my screen shared, but I imagine you guys know how to do that as well. It's probably in here somewhere. Anyway, it's not that important. So let's see, what else? I'm going to post the videos from class. So after class, I will, what's the word? It'll compile, upload it. I got to do a couple editing things, but I usually try and get it up the same day within an hour or so, depending on what I've got going on right after class. So if I'm busy in office hours right after class, I might not be able to get it up until like 4, but I will get all of the classes posted. As far as taking this class, it's graded pass, no pass. A passing grade is 75% or higher. Half of your class grade is based on attendance. Even if you're, so I should point out, some of you are not enrolled in the class, which is perfectly fine. For those of you not enrolled, you don't really have to worry about doing any of the things. So if you don't want to do the quizzes or the weekly reflection or the attendance part, you don't have to. But really, I mean, the whole point of being in the co-class is to get the kind of information out of it. And part of that, I think you definitely do get a lot of feedback from doing the quizzes. So even if you're not enrolled in the class, I do recommend doing the weekly quizzes. I think they're a good opportunity for you to learn something and also to get grade, like I do grade all the quizzes. I give everyone 100% on the quizzes, but everyone gets I still like grade it and give you comments in Gradescope. So if you want to get feedback on material, that is one place you can definitely get it every week. The other thing I have you guys do is a weekly reflection, which is just where you tell me kind of what's going on in your class, maybe tell me a joke, other stuff. They vary a little bit from week to week, but it's a lot of the same stuff. I did, for those of you that have had me before, I did change them up this quarter. So I've got new reflection questions, so it won't be the same thing again and again and again. I mean, some of it's still the same, but it's less repetitive. And yes, so, and again, all of these are completion based. So if you come to class, you get credit for coming to class. Or if you miss a class, and I'll go, actually, I'll get done. So coming to class, you get credit. If you do the quiz, regardless if you get everything wrong in the quiz, as long as you do it and turn it in on Gradescope, you'll get credit for doing that. And then you also get credit for doing the weekly reflections. And they do have, like, I think they expire after like a week after their due date. So please do them in a somewhat timely fashion. They're meant to be kind of done every week so I can have an idea of what's going on with each person. Gives you a place to ask questions. I can answer them, or I can answer them in class. What else? The absence makeup policy. You can make up a maximum of 6 absences. I meant to change that to 10. I'm going to change that to 10, right? Because people who have to miss once a week will definitely be missing 10. Yeah, I knew there was something. I copied this from another Canvas shell where they were missing 6 because they only meet twice a week. 10 absences. I could probably change that right now, literally. Watch me change it. I'm going to edit the thing. And I'll scroll down, and you can miss up to a maximum of 10 classes. Great, perfect. Never was wrong. Okay, so to make up an absence, you just have to watch the video from the class that you missed, and then email me that same week to let me know that you've missed it. I don't want to get a bunch of emails at the end of the quarter, like, hey, James, I watched all these classes. I'll be like, okay, no. Every week, please. It shouldn't be that hard, right? Just send me an email or a message in some other way, shape, or form. Also, stop me if you have a question. Happy to answer questions. This class is worth or carries 1 workload unit. Doesn't apply towards graduation. Does apply towards being meeting your minimum progress as well as financial aid stuff. Also, I think if you're an international student, there might also be some other requirement for that. I would also like to point out the discussion tab. I've been trying to get people to use it. I mean, it's there's a lot of places to interact with each other, right? There's Discord, there's some other thing I saw that people were talking about that I'm not familiar with. But if you want to get help from each other and also have me personally be able to see it, you can go to the discussions, and there's nothing there now, but you can start a discussion and you can be like, hey, James, I have a question. You can be like, hey, question. James, help. I have a question about functions of 2 variables, and so on and so forth, right? And the nice thing about this is about functions. No, I like the way it is. I don't like this autocorrect sometimes. It's not always right. Anyway, you can post a discussion, and then one of your classmates could say something, or like, hey, I have a question about this too. But I will very, very often respond to these with a somewhat detailed answer, or at least guidance about how to proceed. So if you're looking to get help and you would like your classmates to be able to chime in as well as myself, this is really a great place to do it. So I highly, highly, highly encourage you to do it. A few people have done it in quarters past and definitely have gotten rapid responses from me. And I can type math here as well, which is kind of cool. So it makes it easier to like write things nicely instead of just using like your regular keyboard setup. You have like math type options, which is nice. All right, back to the syllabus. What else to say? Some notes about the class. This is kind of just the boilerplate stuff. Each unit in the course is connected to the previous stuff, except for the last section on probability. Feels a little disjointed, but it's all right. How much you should study, definitely. Professor Lewis talked about the Carnegie rule in class today. You got to study a lot for this class. No ifs, ands, or buts about it. Get help. You can definitely get help from me during office hours. You're welcome to send me an email, but I really would encourage everyone. I know I just talked about it. I'm gonna talk about it again. Instead of sending me an email, if you don't feel like it needs to be private, you definitely should try posting a discussion. I will respond to a discussion about as fast as I'll respond to an email. So if you're looking for help with a math problem, think email second and discussion first. But I will definitely respond to you and help you out. But also office hours, right? I'm available in office hours. You should definitely come ask me questions in person. I can write things on the board. You can look at it. I can talk about it. That's probably the best way, because then you can actually hear me say things and I can hear you say things, as opposed to email exchanges or discussion exchanges. There are also other math specialists: Casey, Claire, Duff, Grant, and Sarah. They are also available in ways to help you all. Sorry, I feel like I need to burp, which is going to be great. Anyway, there's also student tutors in online drop-in, and you can also make one-on-one appointments with them at this link here. What else? Here's the AATC website. I always link to Grant's website because I feel like Grant has a lot of great stuff, and I'll get there in a second. My website, which does not. And again, this link here is the same as this link here for drop-in tutoring. So if we look at these things real quick, like here's the AATC website. There's some stuff here, but probably I usually just go to be like, oh yeah, what's the CRN number for my code class? Oh yeah, it's down here. It's, you know, whatever it is, it's 61730, right there. There's other information here, but let's go over to, this is where you can get drop-in tutoring help. I don't think links are live just yet, because usually tutoring doesn't start till like next week or something. This will be, I feel like this hasn't been updated. Let's see, spring break. Yeah. You can book individual appointments here. I encourage you to look at it if you're looking at it. Here's my website, which does not have a lot on it, but it does have links to the classes. It also has links to the link to the office hours. And it also has, where'd you go? Right here, this link is a link to my Calendly, where you can make an individual appointment with me if you are looking for individual help. You can also make an individual appointment with me with a friend. So if you like don't want to be one-on-one, but you like to have like 2 of you or 3 of you, you can do that as well. A couple people did do that last quarter, which I thought was great. So those are lots of the ways you can get help. There was one more thing. And then here's Grant's website, and there's all the things over here. His 17C website. I often use what he's got here as kind of source material, not always, but often. But if you're looking for kind of more information about stuff, this is a great place to try and find it. And this is for the new book. There's also old book stuff, which if you're looking for extra stuff, some of this might not be very applicable, but some of it might be. So you can kind of look through here. Yeah. What else? Let's see. Let's go to the modules. I think that covers the syllabus. And then here's the course summary down here. Great. And then if you look at the modules, there's not a lot yet. There's a bunch of links for graphing stuff. So there's a link for 3D graphing in Desmos and in GeoGebra, which might be worthwhile to check out. There's also a bunch of direction field links, which I know we talked about last quarter very briefly, and we will most likely be talking about direction fields quite, maybe not a lot, but certainly a fair amount this quarter. So those are there for you to use and views. And then here's where I'll put the class recordings after we start having them. And then here's where I'll post, one of the many places I'll post the quizzes and their solutions eventually. That brings me to the assignments tab. So in the assignments tab, you have all the links to the reflections, you have all the links to the quizzes, and then you have the roll call attendance, which you don't need to look at it. Just, I mean, you can look at how often you've attended. And even if you're not enrolled in the class, I will still mark your attendance, because we need to keep track of how many students we serve. So whether or not you're enrolled, I will still be marking your attendance. So if you're like, James, I'm getting all these zeros for attendance because I haven't attended, and you're not enrolled, don't worry about it. If you're getting zeros for attendance and you have been coming, then you should worry about it. Let's look at reflection number 1 and quiz number 1. So here's the first reflection, and basically you just have to type stuff and tell me things about yourself and what's going on in your class. So this first one's a little more introductory. Tell me what name you'd like to be called, where you're from, something interesting, something not interesting, what you went over in 17C this last week, and very, very briefly, like a couple sentences, bullet points. In fact, yeah. Let me make sure. Come on, give me an edit there. Right? You don't need to tell me a paragraph. Like, just 2 to 3 sentences, bullet points, the highlights of the week, if you will. And then what else? A math question. I do like I like to give bullet points. That's fine. We can leave it that way. I do encourage everyone to ask me math questions. It can be something very specific, like from your homework. People send me screenshots often. You can also, if you want, say, hey, James, instead of asking my question here, I'm going to ask it in a discussion. In fact, I'm going to start typing that in the next ones for sure. Reflection, question, and discussion. And then optional, but always appreciated. A joke, a meme, something to make me laugh. I've gotten a lot of good ones over the last 3 quarters, so keep it up. I appreciate them. I expect to see a number of Suez Canal ones. So yeah, maybe not. I know the ship got freed, but I saw a pretty good one today. It was like about how the next ship has an opportunity to do something really epic. Thought that'd be fun. Okay. Anyway, also I would really like all of you, if you can, to pick some sort of photo for your when you are not on camera. Most of you, I actually can't see. Let me go bigger here. Some of you have photos up, which I think is great. If I say about like half of you have photos up, that's great. But about half of you do not. That's also perfectly fine. But if you can find a photo, it doesn't have to be of yourself. It can just be of a thing, something colorful, bright. It can also be totally dark and not bright, but something so I'm not just looking at a black screen with your name on it. Would be great if you can do that. Yeah. And then we also have this quiz number 1. So here will be a PDF of the quiz once it is available, once it's live. I need to fill that, upload a quiz there, which I haven't written yet. I've got some ones from last quarter, 2 quarters ago that I might reuse a little bit. And then as far as, so you'll look at the quiz, you'll do the quiz, and then you'll upload it on Gradescope. So I imagine you've all used Gradescope, hopefully. I'm not logged in, fine. Anyway, so after you do the quiz, take a picture of it, use some sort of scanning app. You'll then click on this to go to quiz number 1. And then since I haven't created it yet, you can't see it, but you will find it here and do the usual things. If you have questions about how to upload stuff to Gradescope, send me an email. I'm kind of imagining at this point, everybody is cool with using Gradescope, but if that is not you, that is perfectly fine. Just let me know and we can totally go over it. But I don't think I need to spend everyone's time doing that because I feel like most of us probably have used Gradescope at least a couple times. Transformer sounds. I think that's kind of it. I'll post announcements from time to time. Often, like if there's a new quiz, I'll be like, hey, the quiz is available, or that's most of it. Or hey, I'm not gonna have office hours now because something came up, or something. Attendance, I will mark the attendance. Like I can, in fact, what I'll usually do is I will take a screenshot of all you guys right now. So I'm taking a screenshot of all of this here. And then I will go mark the attendance later. And then you can also find the files for the class. These files are garbage. You don't need to look at these at all. They're because I copied this shell from my 21B class. I should delete these when I have a chance. Yeah. So let me ask you guys, let me stop sharing my screen. Let me ask if you have any questions. I should also mention, I suppose, that if you were in Karan's class last quarter, if you look at the Canvas shell for Lewis's class, it looks very, very similar. Right? It's the same sort of layout, same sort of assignment, same structure. So if you were in Karan's class last quarter, then you should be very good to go as far as the administration of this class. Things are going to be pretty much working the same way they worked last quarter as far as what you're expected to do. Let me just choke on some water here. What else? What else? What else? What else? Just want to make sure I cover my bases before I start just talking about math. I think it's probably time to start talking about math. I suppose I should say, if you have any questions, you're always welcome to get in touch with me. Oh, sorry, I see there are some questions. So I should also point out, sometimes if I'm looking at other things, the way I have my screen set up, I often end up covering up the chat. I will try my best not to do that, but sometimes it happens. So let's see. What do we got here? We got some questions. How much of 17C is graphing? That's a hard question to answer. I don't think you do a ton of 3D graphing, although we do think about some 3D graphs in the beginning a little bit. There is some graphing of some, so when we move on to talking about like systems of differential equations and solving them and kind of visualizing their solutions, there is some graphing there, but it's actually usually pretty straightforward. It's often graphing like some lines or some parabolas and kind of seeing where they intersect and kind of looking at the different sections of like what kind of sections are different from each other by the intersections. But most of the graphing is not too hard. It's more what we do with the graphs that is more of the challenging part of this class. So there's definitely some graphing, but that's not the hard part, if that makes any sense. And then I see a question from Lindsay. Could you go over section 9.1 a bit? Start the next question. Okay, yeah, I think it was number 27. I definitely got things to talk about, but yeah, I was looking at, didn't seem like he covered too much material in class. He just kind of started talking about functions of two variables. So let's look at section 9.1. Imagine as functions of multiple, functions of several variables, of course. Yeah, okay, cool. That's what I thought we were doing. Now we're talking about limits too, right? 9.1 covers a lot of stuff. Okay. So let's take a look at number 27 here, contour map. Okay, sure. Okay. So I will definitely try to get to that question today, Lindsay, but I do feel like it requires us to kind of build up the machinery a little bit of that. But we'll get there. But let's talk about kind of what all that involves. So the question that Lindsay asked, by the way, is, so they give you a contour map for a function, which we can talk about, and they wanted to use it to estimate the values of f of -3, 3 and f of 3, -2. So let me give you a function and let's draw a contour map. A contour map is also a graph of the level curves. So some people might say level curves, some people might say a contour map. They pretty much mean the same thing. So here's one of my favorite functions to work with because it's easy for me to draw. Let's look at this function of two variables. F of x comma y is 9 minus x squared minus y squared. And I'm going to give you guys a tip, which is that for a lot of functions of two variables, at least in this beginning section chapter, when you see a minus, like an x squared and a y squared together, if it's minus x squared minus y squared or plus x squared plus y squared, if they have the same sign, it really kind of is beneficial to think of those as one kind of unit. So instead of 9 minus x squared minus y squared, I'm thinking of it as 9 minus the whole quantity, x squared plus y squared. And there's a couple reasons for this, but one of them is that x squared plus y squared on its own, we know that x squared plus y squared, no matter what x and y are, is always greater than or equal to 0. And that's kind of important. Kind of. So that's kind of one thing to be aware of. So let's kind of talk about, let's talk about all the things that go with this. We're going to graph this. We're going to talk about the level curves and everything. But first, I actually want to talk about the domain. So when we talk about domain of multivariable functions or functions of two variables, the same rules apply as they did in previous classes, right? You still can't take a square root of a negative. You still can't take a logarithm of 0 or a negative. You still can't divide by 0. But looking at this particular function, none of those things could happen, right? There's no logs, there's no square roots, there's no division at all. So here we have no domain issues. So our domain is everything. But the difference here is before, so let's go back in the Wayback Machine, back to functions of one variable. If my function was like f of x equal to, I don't know, let's say it was 9 minus x squared, we would say, well, okay, I know that the domain here is all reals. Which we could write like that, or we could say, you use the interval notation, say it's everything from negative infinity to infinity. Or we could use the fancy R, right? There's lots of ways to say everything. And we also know the range, right? This is a downward opening parabola. Looks like that. Has its vertex at the point 0, 9. So the range here would be, well, it goes as high as 9 and as low as, well, it keeps going down forever. So it doesn't have a lowest value. So we say that the range goes as low as you want, down to negative infinity, and as high as positive 9. Great. The difference here is that for our domain here, we have to talk about the x and the y values, right? Our inputs is not just one thing, it's two different things. So the domain here is, one way to say it is the entire xy plane. Right, because x and y can both be anything. So x can be 1, y can be 1, or x can be 1, y can be 2, or x can be 3, and y can be 7, or x can be 5, and x can be pi, y can be pi, right? Literally, x and y can each be whatever we want them to be. But it doesn't mean it's the real number line, it means it's the real plane. X can be anything and y can be anything. Sometimes we graph it. We're like, okay, my domain is everything on the plane. And the more kind of official way of writing it is the domain is the set containing all points x and y such that both x and y are real numbers. Essentially, there's no condition on x or y here. But writing the domain or describing the domain of a multivariable function can be a little bit complicated. Let's talk about the range as well, and then we'll talk about graphing it. So for the range here, the range is actually why I noted that x squared plus y squared is always greater than or equal to 0. If this is always greater than or equal to 0, well, then this function is 9 minus something that's always bigger than or equal to 0. So if this is 0, then the function has a value of 9. But if this is bigger than 0, then the function is going to have a value that's smaller than 9. So here our range is actually the same as the function on the other side of this. The range is everything from negative infinity up to 9. We get 9 when x and y are both 0, and we can get any smaller number by letting x or y be the appropriate value. Like if I wanted to see that 7 was in the range, I'd need this whole thing to equal 2. So I could say, well, x is the square root of 2 and y is 0. Or I could say x is 1 and y is 1, right? There's a lot of different ways I could get 9 minus 2. But the point is, it's in the range. There are x and y values that produce 7. The range, yes, in this particular context, the range does represent kind of what z values we get. So just like in this graph here, the range is all the y values you get. In this situation here, which we will graph in a moment, the range is all the z values you can get. Because we often do think of this as, so just like we write, f of x equals 9 minus x squared, or we write y equals to 9 minus x squared, and we kind of think of them equivalently. Same kind of deal here. When you're writing f of x, y equals 9 minus x squared minus y squared, we can also think of this as z equal to a function of x and y, and especially for graphing purposes. So graphing this thing, let's talk about graphing this thing. Yeah, about the other side. Okay. So there's a lot of ways to graph things, but I guess we should try and be very specific. So let's talk about level curves, also known as contour lines. And again, our function is f of x, y equals 9 minus x squared plus y squared. So hopefully you guys all attended class today, but even if you didn't, you've probably looked at a topographical map at some point in your life where, you know, each line, each like continuous line represents everything being at that elevation. And that's kind of the same idea with a level curve. When you're talking about a level curve, you're thinking about graphing this function in three-dimensional space where, right, we've got your X, Y, Z coordinate system. And we're going to input X and Y values and get out Z values. So for example, I could say, well, okay, well, X and Y are both 0, then Z is going to be 9. I think the point is 0, 0, 9. Or, and I don't want to plot too many points because it makes it harder to graph the thing. So I'll plot a couple of convenient points, like say if X is 3 and Y is 0. Right, so I could do like f of 0, 0 is equal to 9. F of 3, 0 is equal to, well, 9 minus 9 plus 0 is 0. So if I go out 3 in this direction, I get that point there. I also get, right, if X is 0 and Y is 3, and then I get 9 minus 0 plus 9. So 9 minus 9 is again 0. Look at this point over here. Oh, was I gonna? I'm kind of getting a little bit ahead, and I don't want to spoil the whole thing, but I'm just gonna graph it. So, I really thought I should talk more about how I'm graphing this. There's a lot of ways to graph this, and the way I'm actually graphing this is I'm thinking about what are called the traces. So the traces are the graphs you get in each of the different planes. So there's the XY plane. So if we're living in the XY plane, your Z value is 0. Right? I'm just in this, right? Like if I kind of think about it like this, if I'm just in the XY plane here, right? I'm in the flat part. You haven't gone up or down, so your Z value is 0. Just like how in 2 dimensions, if you're on the x-axis, y is equal to 0. Same kind of deal here. For the xy plane, z is equal to 0. If z is 0, right, this is z, then you've really got 9 minus x squared plus y squared equal to 0. If you bring this over here, that's 9 equal to x squared plus y squared. That's a circle of radius 3 centered at the origin. So in the xy plane, we've got a circle. We can also look at what's happening in the other 2 planes. We can look at what's happening in the xz plane, where y is equal to 0. So if I set y equal to 0, I get z equal to 9 minus x squared. Well, that's just my downward opening parabola, which looks like that. And then I get the same sort of thing in the yz plane. The yz plane, I'm setting x equal to 0, and I'm getting z equal to 9 minus y squared, which again is the same sort of downward opening parabola. So here's how I'm actually graphing this. In my yz plane, which is I'm thinking of as the flat plane against the board, I've got this downward opening parabola. And then in the xz plane, which is always a pain to draw in, because the xz plane is the one that's like coming out at you, I've also got the same downward opening parabola. Kind of looks like this. And it's also going to go 3 back. And then in the xy plane, which is the the floor essentially, right? You've got this circle of radius 3. So I'm hitting this point and this point and this point and this point. So it's looking like this. It kind of looks like a mountain, right? Or a hill. right? That's what I'm thinking of when I graph this particular function. So that's how I'm thinking about graphing this, right? I'm thinking about what's happening in the YZ plane, the XZ plane, and the XY plane. Now those aren't all level curves. One of them is a level curve, specifically the one in the XZ plane. That's the XY plane. But let's talk about the level curves, because the level curves are the curves that are all at the same height. So let's talk about level curves for a moment. So to find a level curve, you want everything to be the same height. So for example, I know we already did this one, you could set, if we go at our function f of xy equal to 9 minus x squared plus y squared, you could set your function value equal to 0. Well, that's going to lead you to 0 equal to 9 minus x squared plus y squared, or as we saw, x squared plus y squared equal to 9. Great. But we could also pick a different value, right? We could go up. So we could pick, say, and usually we start, instead of saying the function is equal to 0, we usually start saying z equal to 0 or z equal to 1 or whatever. So we can look at z equal to 1. Okay, well, if z is 1, now I've got 1 equal to 9 minus x squared plus y squared. If I bring this over here, I get x squared plus y squared. If I subtract 1, I get 9 minus 1, which is 8. So this is still a circle, but now it's got a radius not of 3, like in this one, but a radius of the square root of 8. And here the radius is the square root of 9, which is 3. Here the radius is the square root of 8, which is a little bit smaller. So if we go up to a height of 1, our circle has a slightly smaller radius. That's the level curve when z equals 1. Still a circle. So as you can see, or at least I think you can see, doing this repeatedly is kind of a pain, right? I'm going to plug in z equals 2, z equals 3, z equals 4, and get different kind of level curves for all those values. There's kind of there's a quicker way to deal with it. What we often do is we say, okay, I don't want to do all that. I'm going to set z equal to c, which is kind of pointless. You could just solve for it without that. But I'm going to do that and then say, okay, if I have c equal to 9 minus x squared plus y squared, what kind of curve is that giving me? Well, if I solve for x squared plus y squared like I did in the previous ones, I get x squared plus y squared equal to 9 minus c. That's going to be a circle with a center of the origin and a radius of, well, the square root of whatever this is. Let's draw the level curves. So when we draw the level curves, we're drawing the contour map, right? We're taking a 3D shape, surface, and we're kind of flattening it down onto a 2D map. All right, so I know that when c equals 0, I'm going to use different colors here. Right, when c equals 0, we get a radius of 3. So let's be kind of very careful here with our So there's my level curve when the height is 0. Right, there's right, if I was traveling and I wanted my height to always be 0, I could stay on this circle, right? I could walk around essentially the base of the mountain. But, whoops, drop things. But I could, I'm afraid I ran out of colors. I mean, it didn't quite run out of colors, but a lot of my colors I run out of. So we could pick terrible values like c equal to 8, c equal to 1. And if c is equal to 1, this is not the pen I meant to grab. The pen is right here. Then your radius we saw is going to be the square root of 9 minus 1, which is the square root of 8. Square root of 8 is like, what is square root of 8? It's like 2.8, I think. That's pretty close to 3. So here's my level curve when c is equal to 1. But what we often do is we kind of pick nicer values. Like I might like to pick, I might like to pick c equal to 5. So pick c equal to 5, then my radius is the square root of 9 minus 5, which is the square root of 4, which is 2. So here, my level curve when c equals 2. And then we could pick another nice value like c equal to 8. I was picking a new pen here. Come on, pens. Get it together. There we go. So we pick c equal to 8. Then our radius is going to be the square root of 9 minus 8, which is the square root of 1, which is 1. So here's what this is showing us. This is showing us that the closer we get to the middle of the x, y, right? So the closer x and y are to 0, the higher the z value is going to be, right? So for example, now, so I'm wrapping back around to the question that was originally asked. I could then use this to estimate the value of my function. Let's pretend we don't know what the function is, even though we totally know what it is. We could say, okay, if this is my level curve, or my, what does the book say here? If this is my contour map for a function f. So this is a contour map for a function f. I could use this to say, okay, well, what's going to be, like, what's f of 1 comma 1? Well, here's 1, 1. So here's 1, 1. I know that if I was right here on the orange curve, f of that would be equal to 8. And I know if I was over here on the green curve, f of that, well, that's a lot of range. Sorry, I maybe didn't take a great example. But the idea is that I can say, well, this is pretty close to 8. I might guess the f of 1, 1 is like equal to 6. I know it's not right, but we're just guessing. But that's kind of the idea. The idea is to say, okay, well, whatever curve we're closest to, we want to kind of guess a value that's close to that value. So I have a good way. You know what? One sec, I do actually have, I forgot I have the book. So just to make sure everyone, let's go ahead and take a look at the book. I rhymed some of the time. Let's see here. Where did I hide the book for myself? Books, 17 series, chapter 9. Yeah, here we go. Share my screen. So here's the question in question. So here's the book. Yeah, wow, it's a long section. There's a lot of stuff in this section. So question 27 was it. So here's our contour map. I can zoom in. Can I zoom in? Let's see. I should be able to, yeah. Oh my gosh. Can I not do that though? Wow. Can that scroll side to side? It's terrible. There's got to be a way to do that. It seems really dumb. Okay, anyway. So the question asks us to approximate or estimate f of -3, 3. So here's what I know already. I know that if I was on like anywhere on this circle here, oh, can I click on this? That's interesting. Anyway, if I was anywhere on this circle, my z value or my function value would be 70. If I ended up on this circle, my z value would be 60. So I can say, just as a different example, if I had like f of 0, 2, so if my point was right there, I would be, well, I didn't quite get to 70, but I'm definitely on the side that's bigger than 70. So I would be like, maybe 75. I don't know. If I look at, say, -3, 3, so I'm going to go, let's see, from here. I really don't. Okay, there we go. I don't like the whole there. Okay. From here, I'm going to go 3 to the left. 1, 2, 3. I'm going to go up 3. 1, 2, 3. So here's what I can say about this. I'm between 60 and 50, right? I'm between this level curve, which is a height of 60, and between this level curve, which is a height of 50. So I might guess, it looks like it's a little closer to 60, so I might guess something like 56, 57. But the point there is just to guess. And then you can do the same thing for 3, -2. So you go over 1, 2, 3 to the right and down 1, 2. It looks there you're probably between 30 and 40. And it looks like you're pretty evenly between. So that's kind of the idea, is that the contour map tells you what the z value would be if you know the x and the y coordinate. Same kind of deal here, right? If I knew that the x and y coordinate was say 2, 0, I go over 2, up 0. Oh, I'm on this level curve. The y value is definitely going to, the z value is definitely going to be, I'm sorry, I wrote the wrong thing there. I'm like, what's going on there? That should be c equal to 5. Apologies. It was a circle of radius 2. It was c equal to 5. Sorry about that. So let me stop sharing here for 1 second. I can figure out how. Right on this here, right? If we said what I want to know what f of 2, 0 is, I can go over 1, 2, up 0. Like, okay, I'm on this level curve perfectly. What's the z value? Oh, the z value is the level curve value, which is 5. So those contours, those level curves, tell you what the z value or the function value is, depending on like where you are on it. Let's see. Let's look at one more. I know we only got a couple minutes left. Let's look at one more quick example, just because I want to show you an example of something where the domain and range is kind of interesting. Do I? Yeah, I do. Let's say we have this function. Let's say our function f of x comma y was equal to the square root of 16 minus x squared minus y squared. Just want to talk about domain and range of this for 1 moment. So for the domain, now we actually are limited, right? For the domain here, x and y can't just be anything, right? If x was 5 and y was 0, that wouldn't be allowed, because you'd have 16 minus 25 minus 0, which would be -9, and we can't take the square root of a negative number. So here we are limited by the fact that the insides have to be greater than or equal to 0. I still recommend treating x squared plus y squared as kind of 1 unit. So I'm going to think of this as 16 minus x squared plus y squared is greater than or equal to 0. Or preferably, adding this to both sides, 16 is greater than or equal to x squared plus y squared. Well, I know what x squared plus y squared equal to 16 looks like. That's a circle. There's a lot of circles in this section. That's a circle of radius 4. So I'm going to draw my domain. With my circle of radius 4, okay, 1, 2, 3, 4. And here's the thing about domains in the xy plane. Usually, if you've got some sort of boundary, right, because we need x squared plus y squared to not equal 16, but to be less than or equal to 16. So we definitely want to include this boundary because those points satisfy this inequality. Right? For example, the point here, 0, 4, definitely good, right? 0 squared plus 4 squared is definitely less than or equal to 16. Same thing here, right? 4, 0 is good to go as well. And then what almost always happens is you either get everything on the outside of your thing, or I should say one side, because sometimes your boundary is like a line. You either get everything on one side of it or the other side of it. So here you either get everything inside the circle or outside the circle. And the way you can check is by testing a point. I'm going to test the point 4, 4, which is definitely not in the circle. So if I pick x equal to 4 and y equal to 4, 16 plus 16 is 32, and 32 is not less than or equal to 16. So that point is not in your domain, which means everything else, which means everything on the other side of the boundary is in the domain. So our domain here is everything inside the circle of radius 4 center of the origin, including the boundary.